Okay guys, so we're going to go ahead and work problem 7, the matrix problem. But we're not going to do the whole problem. We're just going to put it together and I'll leave you to solve the matrix. And in reality, the matrix is so simple that you could solve it in your sleep. The hardest part is just setting everything up. So I think you'll agree. It's best just that we save our time and work on what is most important. Here is figuring it out. Now the first thing that I'm doing here, as you might have noted, is that I'm separating out the information that we need because, of course, it's critically important. Especially because the majority of the time, these problems will seem almost impossible to figure out without really analyzing them. So just be systematic. You don't know what's going on? No problem. Let's see what we can put together. Okay. So our first sentence. What does our first sentence say? Okay, our first sentence says that David, okay, the number of sisters is twice as many as brothers. Okay. So what this is saying is number of sisters equals twice the number of brothers. Now right here I'm going to stop and I'm going to show you something, okay, because some of you may actually think that the statement was actually backwards because it reads backwards. It says twice as many sisters as brothers. So you may think it says twice the number of sisters equals the number of brothers. Okay, but this here is absolutely wrong. Okay, I'll tell you right now, you'll see why it's wrong. And it's really easy to figure out because whenever you're in doubt, if you're in a test, just set a really, really simple test. That's a really simple example. In this case, why don't we say that the number of sisters is 2? Well, 2 equals 2 times 1. Notice that the number of sisters is twice the number of brothers, right? Whereas if we were to do it this way, okay, notice if we said 2 times 2, well, we're going to get 4, okay? And, okay, 2 is not double 4, it's half of 4. That should tell you that you're backwards, okay? If you read this, you'll notice that this is the statement that makes sense. Okay? So from that then, we conclude that, yeah, the other way of reading it is wrong. Okay, so let's move forward. And we write this up as variables, and that is we say that DS, of course, David's sisters, is equal to twice the number of David's brothers. Simple enough. And just in case we need it, I usually like to set my things up to 0. Okay? You might be like, why more trouble? Well, maybe not. You'll see. Minus 2db equals 0. You actually don't need to do this extra step, but later on you're going to end up doing it anyway, so I'm just doing it ahead of time. So if you don't do it, nothing wrong. The only difference is it'll take you a little longer to solve the problem. Okay. Now, let's go to Liz. We use exactly the same logic, which is the number of sis equals the number of brothers. What does that tell us? Well, that just tells us that Liz's sisters equals, okay, Liz's brothers. And if we do the same shuffling, that just means that LS minus LB equals 0. Right? Right. But now let's look at something kind of concerning. Okay. Look at this amount right here. And look at this amount right here. and look at this unknown, and look at this unknown here, and look at this unknown right here. Now you should notice, okay, what are we looking at? Well, we are looking at four unknowns. And that is unsolvable if they remain unknowns. We cannot solve four unknowns with two equations. We would need four equations. So, are we stuck? Well, that depends. Is there anything we can do to turn them into two unknowns? So why don't you stop the video for a few seconds and think, what can we do? Okay, I hope you stopped it and thought about it. Okay, I know if you're lazy, you probably didn't. I really hope you did, because the opportunity you have to struggle through it is really what is worth it, okay? Me just handing you everything won't solve it. But anyway, here's the point, okay? In this case, we can reduce them by looking at the fact that sisters are female and brothers are male. This is female and this is male, right? Okay. But we can't just replace we cannot just replace the quantities, because there is a very important problem that's going on, which is, first I want to show you I'll show you right here just by giving you the simplest of other examples. We have a family where we have one sister and we have three brothers. Okay? And now, in this example, okay, you're going to notice that if you ask the sister how many brothers and sisters she has, she's going to say she has 3 and 0. You ask the brother and how many brothers and sisters he's got, and he's going to say 2 and 1. That should tell you that each of these numbers, based on who was asking, all four of them are going to be different. That's why I said they're four unknowns. They are males and females, okay, but they're unknown. So then how do we solve this? Well, what we can do is, while we are converting to males and females, we also have to correct for the person that is in the count. Okay, so let's go ahead and let me go ahead and explain that. Okay, so let's go look at David's statement. Okay, so David's statement says David's sisters equals 2 times David's brothers. Okay, and here, if we say this is females and they say this is males, okay, here's the thing. When we say females and males, okay, if we're counting this statement as total females and total males, okay, this for David, remember we're in blue, okay, we have to keep in mind that for David's brothers, how many brothers would he have? Well, he'd have the number of total males minus 1. Okay. How? Well, let's go back to this example here. Okay. Now, in this example here, okay, let's look at this guy. Let's look at the male here. Okay. We're going to look at this guy right here. And how many brothers does he have? Well, he has 1, 2. So he's got 2 brothers. Okay. But how many total males? Well, there's 3 males. Right? Now, let's look at the sister. Just so you'll see again. I hope you're noticing the logic here. Okay, for the sister, okay, how many brothers does she have? Well, she's got 3 brothers. And she's also got 3 total males. So the sister doesn't change. The brothers do because we're counting the brother. Okay, but for the sister, now if we're counting her amongst the sisters, well, remember that she's got 0 sisters and she's got 1 total female. So notice what this is telling us. Okay, it's telling us that the total number minus 1 equals the siblings that you belong to. For sisters and for brothers, I want you to sit there and think about that for a second. I'm going to draw the other one and you'll see exactly what I just said, which is now, okay, LS equals LB. Okay, and here we're saying that Liz's sisters is exactly the same as females minus 1, using exactly the same logic as up here. And this uses exactly the same logic. I know it's not natural to see how that's doing. That's why I showed you this really simple example, and I hope you'll stop the video and think about it. Okay? Think about it. I know, even if I drew it like for 10 more minutes, it'd still be hard to get. But think about it. Okay? I also, when I showed you these, I showed you that if we're counting the sisters that you don't belong to, for example, in this example, if we said for this one guy, for the guy in orange, okay, if we said how many sisters does he have, well, we know he's got 1 sister and he's also got 1 total females. So we don't have to adjust those numbers. So DB in this case, okay, is adjusted, but DS doesn't adjust, so it just becomes sisters, or females, sorry about that. Remember, we're converting to males and females. Okay? And Liz's brothers just convert completely to males. So now we've got our conversions, okay? These are our conversions. And now we can, oops, let's keep our colors consistent so you don't get confused any further. Okay, so now we can plug them in, okay? And so now this plus this plus that all become F, okay, equals 2m minus 1. Okay, and then this one down here becomes, okay, F minus 1. Remember that that's that and that and that, all 3 of those, equals, okay, M. So now you notice we've got our 2 unknowns. This is why we were going to set them up like this over here. Now we set them up. And so what do we get? We get F minus 2m plus 1, or I'm sorry, plus 2 equals 0. You see where I got this, right? That's this guy here. It's just distributed, 2m minus 2 becomes minus 2n plus 2 on the other side. Okay. Then we've got f minus m minus 1 equals 0. Okay. And at this point, we have the columns we want. Okay. So let's look. We have our F column. We have our M column. Now, whenever you have numbers that don't have unknowns, you will just move them to the other side, because they do not belong in the M column. They do not grow and change with M. They are constants. Okay. So now I'm just going to convert this to the full-on matrix, so you'll see. Okay. So at this point, I think you'll agree that we have 1 minus 2 minus 2, okay, 1 minus 1, and 1. And so from here on out, you should be able to solve this. And your number is going to be a really easy number. And remember, you're not going to get decimals or fractions. You can't have half a sister. I'm sorry, but she's not going to live, okay? So you're going to get whole numbers or integers. And it's going to be simple. If you start getting crazy numbers like 23 or 13 or something like that, you're off, okay? So hopefully I leave you with that, and good luck.